Alright, so in this video we're going to be going through the introduction to limits. Now limits is more of like a calculus type of topic, but in pre-calc we kind of have an introduction to it as well in our textbook. So even though it's calculus, it's something that is better if it's like taken conceptually. So what a limit is, it is the value that the function is approaching. And one thing to point out is it is not the actual value of the function. So let's take a look at this visually. Let's just say the graph is something like that. Let's say we're trying to reach the limit of 2 over here. So as x is getting closer and closer to 2, going this way and going this way from both sides, what value do you think y is approaching? So y would be approaching, y get closer and closer to 4. Because let's say like you start off with like when x is equal to 4, the value of y would be like -3 or something like that. That'd be pretty far off. But as you get closer and closer to the value of 2, once you reach like 3, when x equals 3, I'll just graph this out. So this is x, this is y. So we start off with like x equals 4, that's like y equals -3. And when x is 3, y equals 0. And you see how we're getting closer to 4 up here. And let's go back, let's skip 2 and go to 1. Once we're at 1, the value of y would be 3. And when x equals 0, the value of y is 2. So as you can see, the value of y is increasing from 4 to 3, and from 0 to 1, it's also increasing as well. Well, that matches with our graph, and you can see how like it kind of pinches towards the value of 2, and that's what a limit is. It's when the value of the function approaching from the left and the right side. So you can see as the value gets closer and closer to the value of 2 from the right side, from 4 to 3, it gets closer and closer to the value of 2, from -3 to 0. And as the value of x approaches closer and closer to 2 from the left side, from 0 to 1, the value gets closer and closer to 4, which is the value of y when x equals 2. And that is the definition of a limit. Alright, so here's a new graph with a new function. There's something else I want to point out before we start with this problem. You can see over here, these two limit functions have different notation. They have a plus and minus sign where the exponent is. So what this means is, I'm just going to write it a bit bigger. So when x is approaching -1, and let's do the minus sign first. This means that it's coming from the negative side. So it's going from, so this will be the limit as it approaches from the left. And if it's if the limit is x is approaching to -1 plus, then that is reaching the limit of -1 going from the positive side, which is to the right. So that's just a brief heads up of what that notation means. So we could go through these 3 problems up here. So the limit as x approaches to -1, if it doesn't say, it's going to the limit from both sides. So we can see that as it reaches to -1 from the left, and as it reaches from -1 to the right, it reaches, let's say it's this value over here, because it looks like around there. So it'll be when the limit of x approaches -1, the value is 1. But let's take a look at it from here. If the limit of x approaches -1 from the right side, because this is plus, you only take into account of the value going from the right side, which is also 1. And we don't consider this side at all for going at it from the left side. When we take a look at the limit as x approaches -1 from the negative side, you only take into account this left side and not the right side, which is also 1. Now this makes sense because as the limit approaches from from the left and to the right to -1, they both reach the same value. But let's take a look at this other point over here at when x equals -5. So when x approaches -5 from the left side, the value would be around like -1. But when the limit, because it's going at it from this way, but when the limit of x approaches -5 from the right side, that's going at it from here. And just to point out, if there's like a break in the function, but that's not where it stops, you just hop onto the other side. You just hop onto the other section of the function. So you go from here, then you jump to here, and you just continue on. And as x approaches -5, it gives us the value of 6 for y, or it's actually more like 5.5. So yeah, you can see that there's different values here. So when the limit of x gets closer to -5, you can see that as it approaches -5 from both ways, there's two different values here from the left and to the right. And what happens here is that the limit does not exist because there's two different values. And another way that the limit does not exist, I'm going to put it over here, is if there's like a sinusoidal and it like goes something like that. If the limit is like, let's say like for this, in this case, the limit is x approaching 0. There's actually there's no set pattern, or there's no set value that the sinusoidal is approaching. Because like if you take a look at over here, and when x is approaching -1, you can see there's like a definitive value going there. But if you look over here in the sinusoidal, it's always going to go up and down in between the maximum and the minimum value. So there's not going to be a definitive value as x approaches 0. So what we put here is also x of the limit does not exist.